We're never going to stop exploring the unknown in air and space.
We have ignition and we have liftoff.
Response was normal also.
For over 45 years, NASA's Voyager 1 has persisted in outer space. However, it just received an alarming reply to a message it had sent over 25 years ago. Voyager 1 has been sending us valuable data from the most unreachable parts of our solar system. Right now, this spacecraft can be found almost 24 billion kilometers away from Earth, but things are changing. According to predictions, we could lose contact with Voyager 1 forever.
Crossing over into interstellar space.
Voyager accomplished its mission so brilliantly, and now goes on.
Join us as we explore the data Voyager 1 has been recently transmitting, leaving some of the most capable experts confused. The Voyager 1 and its journey. In August 2012, the Voyager 1 spacecraft was officially sent into interstellar space. This began a journey that has been ongoing for decades now. NASA didn't even formally announce this event until the next year in 2013. But there was a reason for that. They wanted to give scientists enough time to look at the data that was being sent back to Earth by the spacecraft. Voyager 1 isn't the only one of its kind. It is one of two spacecraft, both of which were designed for the same purpose of space exploration. But Voyager 1 went through the challenging passage past the gas giants, Jupiter and Saturn, before its twin did. It captured some of the most vivid images during its close encounters with these planets. Since then, these images have become part of educational material and can be found in school books and various media outlets. According to NASA's Jet Propulsion Laboratory, Voyager 1 has been impressing experts with its durability and longevity. Its fuel reservoir is substantial, which ensures the continued operation of its scientific instruments. This resilient explorer is projected to continue its scientific adventures and data transmission capabilities until at least 2025. By then, it will be approximately 13.8 billion miles from the Sun. Through this mission, experts hope to yield further revelations about the cosmos, expanding our understanding of the universe's vast expanse. Voyager 1's missions took advantage of a rare planetary alignment that occurs only once every 176 years. Through this alignment, the Voyager spacecraft could use gravity assist maneuvers to travel efficiently from planet to planet, which also helped them save fuel. The grand plan. Originally, NASA planned to launch 4 Voyager probes. 2 of these were supposed to visit Jupiter, Saturn, and Pluto, while the other 2 were to visit Jupiter, Uranus, and Neptune. However, due to budget constraints, NASA was forced to reduce the mission to 2 spacecraft. Voyager 1 focused its investigations on Jupiter and Saturn, while Voyager 2 embarked on a grand tour of all 4 outer planets. Both spacecraft came back with tons of valuable data and insights, helping experts to better understand these distant worlds. Both Voyager spacecraft are powered by 3 radioisotope thermoelectric generators. RTGs convert the heat generated by the radioactive decay of plutonium into electricity, which is basically what powers the spacecraft's instruments. Each Voyager spacecraft is equipped with 10 scientific instruments, including a 2-camera imaging system.
One that's traveled farthest from home. Voyager 1. She bears a message to 1 billion years from now.
Multiple spectrometers, a magnetometer, and instruments that detect low-energy charged particles and high-energy cosmic rays. The Voyager's communication systems have even been repurposed to facilitate the study of planets and moons, resulting in a total of 11 distinct scientific investigations carried out by each spacecraft. Establishing possible communication with extraterrestrial beings, expecting the Voyager probe's eventual journey into interstellar space, NASA created 2 golden records that were affixed to each spacecraft. Within these records was a diverse collection of sounds and images, including music from different cultures, spoken greetings in 55 languages, and instructions on how to access the record's contents. The golden records are each 12 inches in diameter and are made of gold-plated copper. They also include visual elements, such as a diagram of the Sun's location relative to nearby pulsars. The idea of these records was first proposed by Eric Burgess, a British consultant, to astrophysicists at the Planetary Society. Together, they created the basic design for the first interstellar postcards sent to our mysterious cosmic neighbors, explaining the essence of humanity and its accomplishments. Some elements of these iconic plaques may seem obvious to us today. For example, the two humanoid figures, loosely inspired by classical Greek sculptures and artistic sensibilities, drew a lot of scrutiny during their creation. Some criticized the depictions for being too explicit. The figures have a diverse range of racial features, an intentional inclusion to emphasize our global diversity. However, one department at NASA censored the image due to concerns about the female character being too revealing. Interestingly, an extraterrestrial observer might have difficulty understanding the meaning of the race at hand, which is a friendly gesture, but it was left unchanged as it shows all 5 fingers, including the crucial opposable thumb, a key human feature. The pivotal components of these plaques, however, are their scientific and symbolic representations. The upper left corner of one plaque features 2 circles that represent a hydrogen atom in its 2 fundamental energy states, symbolizing the electron's transition between higher and lower energy levels. This jump between states results in the emission of radiation with a wavelength of 8 inches, a phenomenon that is common throughout the cosmos. Scientists believe that this knowledge would be essential to communicate to any potential extraterrestrial recipients. Between these 2 atoms, a vertical line clearly represents the binary numeral 1, a crucial concept in mathematics and science that symbolizes our numerical system. An eventful history. The Voyager 1 spacecraft had a rocky start. Its rocket almost ran out of fuel, but it managed to launch successfully and even ended up being faster than its twin, Voyager 2. In April 1978, Voyager 1 sent back its first images of Jupiter from 165 million miles away. Each Voyager probe has a memory capacity that is about 3 million times smaller than a smartphone, and they transmit data at a rate that is about 38,000 times slower than 5G internet. In March 1979, Voyager 1 came across a new ring around Jupiter, along with 2 new moons, Thebe and Métis. The spacecraft also took detailed images of Jupiter's 4 largest moons, Io, Europa, Ganymede, and Callisto, as well as the moon Amalthea. In the images that Voyager 1 captured, Jupiter's moons looked more dynamic and diverse than scientists had previously predicted. On the other hand, the photographs it took of Europa showed a smooth surface that was marked by several interesting lines. You could see hints of ice, or maybe even an ocean present beneath the surface. After further observations, it was confirmed that Europa probably has an ocean beneath its surface, and it was considered a real possibility that this ocean could support life. On March 5, 1979, Voyager 1 made its closest approach to Jupiter, passing within 174,000 miles of the planet's cloud-shrouded upper atmosphere. After it completed this exploration, the spacecraft moved on to its next destination, the ringed planet Saturn. Voyager 1 first came across Saturn in 1980, just a year after its very close encounter with Jupiter. After that point, several of Saturn's secrets were revealed. With its high-resolution cameras, the spacecraft discovered 2 new moons, Prometheus and Pandora. They both had played an important role in keeping the icy particles of the F-ring in orbit. But among the most interesting celestial objects Voyager 1 came across at Saturn was the moon Titan. This body had a thick orange haze, making it tough to see its surface. Titan managed to spark years of speculation about its true nature, and it wasn't until the mid-2000s that the European Space Agency's Huygens probe was able to penetrate Titan's haze and reveal its surface for the first time. After its encounter with Saturn, Voyager 1 was onto a new phase of its mission, which required it to monitor its own journey as it traveled into interstellar space. 2 decades before crossing the boundary into interstellar space, another mark in spaceflight history was made by Voyager 1. Its camera turned back towards Earth in 1990 and captured an iconic image of Earth from a distance of 3.7 billion miles. As a result, Earth could be seen as a tiny blue dot suspended in a sunbeam. Voyager 1 also caught images of the other 5 planets and the Sun on that day. It eventually created a multi-image solar system family portrait, which remains one of its most memorable images to this day. Leaving the heliosphere, Voyager 1 left the heliosphere in August 2012. By doing this, it achieved a massive milestone in space exploration.
It's magical. They're really going to put a record on a spacecraft and shoot it out of the solar system? Really?
Experts on Earth knew about this when they observed the density of electrons near Voyager 1, which was way higher outside the heliosphere than inside. One would expect the density of electrons to decrease as one moves further away from the Sun. But strangely, this wasn't the case for the spacecraft. This was explained by the fact that the electron density at the edge of the heliosphere is much lower than the electron density closer to Earth. Researchers looked at Voyager 1's data and decided that the spacecraft managed to cross the boundary of the heliosphere on August 25, 2012. When it was leaving the heliosphere, Voyager 1 was about 11.25 billion miles away from the Sun, which comes up to approximately 121 AUs. 1 AU is considered to be the average distance between the Earth and the Sun. Transmissions from interstellar space. Voyager 1 is still providing valuable insights into interstellar space, the region beyond the Sun's influence. The spacecraft has revealed that cosmic radiation is very strong in interstellar space. It has also helped us to understand how charged particles from the Sun interact with charged particles from other stars. Voyager 1 has amazed both engineers and space enthusiasts. When NASA announced that Voyager 1 had successfully used its backup thrusters to reorient itself in 2017, everybody was fascinated by the prospect of it finally being able to communicate with Earth. This was a big deal because Voyager 1 had not used its backup thrusters since 1980 when it flew past Saturn. The spacecraft had mostly been using its regular attitude control thrusters to navigate and communicate with Earth. Since the thrusters were starting to show their age, NASA knew they had to test the backup thrusters so that they could extend Voyager 1's mission life. They managed to get through this test successfully, and Voyager project manager Suzanne Dodd confirmed that the spacecraft's mission life could be extended by 2 to 3 years. But they wanted the spacecraft to last much longer than that. To achieve that milestone, the team decided to turn off its cameras after it took the famous pale blue dot photo. The camera was useless for observations in deep space because there was no light. Over the years, the team decided to turn off 5 other scientific instruments, leaving Voyager 1 with 4 working instruments, namely the Cosmic Ray Subsystem, the Low Energy Charged Particles Instrument, the Magnetometer, and the Plasma Wave Subsystem. Voyager 2 went through a similar fate, with some of its instruments getting turned off, but it still has 5 working instruments on it. In 2022, both Voyager spacecraft celebrated their 45th year in space. NASA's director of the Heliophysics Division, Nicola Fox, said that the Voyager missions have brought a massive change in the way that the world looks at and understands space. Linda Spilker, Voyager's deputy project scientist at JPL, said that the Voyager missions have shed light on how the Sun interacts with particles and magnetic fields in the uncharted space beyond our solar system. With this brand new knowledge, some previous theories have already been overturned. Plus, every little bit of information that the Voyager spacecraft sends back will be used to make future missions successful. A past of strange signals. In May 2022, a mystery arose. The information from the spacecraft's attitude articulation and control system did not match the actual conditions on board. According to NASA's Jet Propulsion Laboratory, the AACS, which was keeping Voyager 1's antenna pointed at Earth, was fine, but there was something else wrong with the spacecraft. The telemetry data that it was sending back didn't make any sense, and when examined closely, this data was random and unrelated to the system's expected operating state. Surprisingly, this anomaly didn't end up triggering any of the spacecraft's fault protection systems. Experts noted that Voyager 1 did not go into safe mode and maintained its signal with the Earth as strong as it always is. Suzanne Dodd, the JPL project manager for Voyager 1 and 2, had a balanced perspective to offer. She said that such mysteries are pretty common at this late stage of the Voyager mission. She pointed out that these spacecraft have far exceeded their expected operational life, approaching 45 years in service. Plus, they are now traveling through an environment that is unique in human space exploration. Interstellar space, which is characterized by high levels of radiation. As a result, encountering perplexing occurrences that require thorough investigation and resolution over time is, in a sense, to be expected. While the source of this puzzling anomaly remained unknown for a while, things finally made sense 3 months later. According to NASA engineers, the problem was with the spacecraft's AACS, which had been sending its telemetry data through a computer that had been broken for a long time. This caused the data to become corrupted, so the data that NASA received on Earth was seemingly random. NASA quickly fixed the problem by telling the AACS to start sending its data through the correct computer again. This worked, and NASA was then receiving good data from Voyager 1 again. To this day, NASA doesn't know why the AACS switched to using the broken computer. They think it may have received a bad command from another computer, but they don't know which computer or what caused the bad command. Suzanne Dodd, the project manager for Voyager, said that they were going to look at the AACS's memory and see everything it has been doing. This was going to help them figure out what caused the telemetry problem in the first place. Overall, they were optimistic, but they still had a lot of work to do. A Heartbeat Voyager 1 may be faster, but it's not the only one sending back strange signals. In mid-2023, a massive issue was faced by the probe on Voyager 2. Unexpectedly, it deviated from its course by 2 degrees, owing to an erroneous command. This made Voyager 2 lose its ability to receive commands or transmit data back to Earth, which left experts confused. The disappearance of the spacecraft was sudden, and all NASA could do was wait. Later, NASA announced that the spacecraft had flipped a value in a single memory location from a 0 to a 1. A cosmic ray event probably interfered with its electronics, and such a small shift led to the complete blockage of communication. However, after a few weeks went by, NASA was able to detect a reassuring heartbeat signal from Voyager 2 during a routine sky scan. Contact was soon re-established with the spacecraft. As of the latest update, Voyager 2 can be found 12.3 billion miles from our home planet, traveling through interstellar space at an estimated speed of 34,390 miles per hour. So getting in contact with the spacecraft was not easy. Voyager 2's communications blackout remained steady since July 21, 2023, as it got entirely cut off from NASA's Deep Space Network. But with the detection of the signal from Voyager 2 once again, experts were reassured that the spacecraft remained operational and in relatively good health.
Mystifying man since the dawn of history, Saturn bears the name of the mythological god of the harvest, who reigned in the Golden Age.
Just so you can understand how tough this ordeal was, it's important to know that the signal takes about 18 hours to reach Earth due to its massive distance from our planet. NASA's Jet Propulsion Laboratory, which oversees the Voyager missions, had been actively working to restore contact the entire time. Voyager 2 was gone. Apart from monitoring signals, they had been sending the correct command sequence in the hope of reconnecting with Voyager 2. While comprehensive communication had not been fully restored, Voyager 2 was programmed to undergo multiple orientation resets each year to ensure that its antenna remains pointed toward Earth. The next reset, scheduled for October 15th, was expected to facilitate the resumption of communication. Throughout this period of communication disruption, NASA expected Voyager 2 to maintain its trajectory as planned. The blockage of communication didn't mean that the spacecraft would stop doing its work. It only meant that experts on Earth could no longer monitor what the spacecraft was doing. On a lighthearted note, NASA took to social media to announce that Voyager 2 was taking a break from sending data until October. They reassured that no harm had fallen on the spacecraft and that it would be back in contact soon. Now, NASA has steady control over both the Voyagers. Spacecraft discovering intelligence SETI, or the search for extraterrestrial intelligence, made a curious discovery on August 24, 2022. Some signals were detected by the unique radio telescope named the Allen Telescope Array in Northern California. The reason this telescope was built was to conduct the SETI research, and at first, they thought that these signals were coming from aliens. However, they realized later that NASA's Voyager 1 spacecraft was the reason behind these signals. Both scientists and space enthusiasts were excited at the prospect. They have majorly upgraded the ATA since 2019 to improve its ability to explore the cosmos. That is probably how, on July 9th, 2022, the upgraded ATA was able to find and capture Voyager 1's carrier signal. Wael Farah, a radio scientist at SETI, discussed the discovery and its implications for the search for extraterrestrial life. The entire structure of the ATA has 42 individual radio antennas, all of which are busy picking signals from one place or the other. Farah explained that the radio signature they received from Voyager 1 was extremely similar to the signs of extraterrestrial life that SETI researchers are eager to uncover. Because of this similarity, Voyager 1 became an attractive target for the experts. Detecting Voyager 1 was a massive discovery for Farah and his team. The hard work that they all put into the process was real, and when they finally saw the line on the computer screen that indicated they had captured the signal, it was an exciting moment for everyone. Farah is excessively proud of what his small team has accomplished over the past 3 years. Detecting Voyager 1 in the search for extraterrestrial intelligence has several implications, one of which gives the SETI community confidence that they can detect other signals. These can be found as narrowband transponders, or beacons like the one on Voyager 1. While they could have used simulations and synthetic data tests to test their model's abilities, detecting a real sign made things way more exciting for them. It was proof of the fact that their model was actually working. Although they knew that other similar signals would be too weak to decipher, they were one step closer to unraveling extraterrestrial life. But there was one question on everybody's mind. Would an alien probe need to be close to Voyager 1 in order to be detected by the ATA? According to Farah, it is a real possibility, but it definitely isn't necessary. All that matters at the end of the day is the strength of the signal. A beacon halfway across the galaxy would need to be much stronger than Voyager 1's transmitter in order to be detectable. What this means is that it is possible for extraterrestrial civilizations to use similar technology to communicate with us. The moment they detect a signal would answer the age-old question of whether we are alone in the universe, the possibilities of the Voyager map. Each Voyager has a map etched onto its body, but it is way more than a simple map. It is a message that was designed to communicate Earth's location and the duration of the spacecraft's journey to any alien beings who find it. Frank Drake, a famous astrophysicist, created this map while keeping a lot of things under consideration. While giving aliens a glimpse of where we're from, he also wanted to let them know how long the spacecraft has been traveling through space. Many maps were created before it, but this one stood out. It uses 14 pulsars, which are neutron stars formed from the remnants of massive star explosions. These can find our sun's position in the Milky Way galaxy, and there is a very complex concept behind it. Through the Voyager, our fascination with the cosmos and our desire to learn more about it can be clearly seen. Contacting aliens is not easy, and the consistent struggles of these spacecraft are proof of this fact. But some people think it's a bad idea to broadcast our presence to aliens in the first place. They find themselves worrying about the dangers attached to this announcement. Others, however, believe that it's important to reach out and make contact with other forms of life. This may be the only way to learn more about the universe and our place in it. Dr. Catherine Denning, an anthropologist at York University, says that when the Voyager map was created in the 1970s, there was nearly no debate about whether it was a good idea to contact aliens. But now scientists have found themselves more divided on this issue. Some scientists think we should be cautious and just listen for signals from aliens. Others believe we should send out messages of our own. This debate will probably continue as we learn more about the universe and where we stand in relation to it. While Dr. Frank Drake's cosmic directions for aliens on the Voyager Golden Records were created in the summer of 1977, the map was started years earlier, in 1971. At that time, Dr. Drake and Carl Sagan were working together on a message to put on the Pioneer 10 and 11 spacecraft. Set to leave our solar system after flying by Jupiter, these probes offered great promise. But one of the things Drake and Sagan wanted to include was a map that showed where Earth is in space and time. Now here was the biggest challenge they faced. They wanted to make a map that aliens could understand. After a lot of thought, they decided that Earth years were not a good unit of measurement because they are based on how long it takes Earth to orbit the Sun. Coordinate systems were also an additional problem because in space, the directions we use on Earth, like up, down, east, and west, are not useful for navigating. The fact that the stars are always moving made things even more complicated. Over time, even stars themselves change a lot, so traditional landmarks are not helpful. Frank Drake eventually solved the problem of making a map that aliens could understand using pulsars. These are stars that have collapsed into very dense objects and spin fast. They work by sending out regular pulses of radio waves, like a lighthouse. With its own unique spin rate, each pulsar stands out differently, even though this rate slows down over time. Drake realized that if he put the spin rates of 14 pulsars on a map, aliens could use this information to find Earth. They would do this by comparing the spin rates on the map to the spin rates of pulsars they could see in the sky. The difference between the two would tell them how long ago the map was made. Drake drew the first pulsar map by hand. He used 14 well-known pulsars and showed their distances from the Sun. This process also included encoding the pulsars, spin rates in binary code, a way of writing numbers using only 2 digits, U and 1. If aliens found the pulsar map and could read it, they would know where Earth is in space and when the map was made. A grave threat. When Voyager was launched, astronomers had no idea about the other planets beyond our solar system. Planets that could support life were merely concepts, and nobody expected that there was any extraterrestrial life beyond movies. Back then, space was a mystery, but today we finally know that planets are common in the galaxy. The possibility that some of them may be like Earth stands glaring at experts, and this has led to new ideas for sending messages to star systems that might have life. But the debate of whether aliens should be contacted or not is a long-standing one. Some people think that we don't know what they're like, which is why this could be a risky move. According to them, we should just listen to messages from them instead of calling them to us. In the opinion of the creator of the Voyager map, the chances of aliens finding the spacecraft are very slim. The spacecraft is traveling extremely fast, and since they're not aimed at any star in particular, it's not very likely that anyone could just stumble upon it. But Drake also points out that humans have been sending out radio and TV signals for almost a century. Aliens could easily detect these signals, even if they're not aimed at them. Catherine Denning, an expert in space communication, says that we should be careful about sending messages to aliens. Consideration needs to be put into all the possible consequences, both good and bad. A reply from aliens. A study, which has been posted on a preprint server, found that 5 exoplanets could have received signals from the spacecraft. By the year 2100, there's a chance that aliens from these planets send their own messages back to us in reply to our signals. The study looked at Voyager 1 and 2, which are already traveling through interstellar space. After communicating with radio antennas on Earth, the signals from these spacecraft have been traveling out into space. Out of the 2 spacecraft, Voyager 2 was especially interesting during this study. To get the desired results, the study's authors used the beam width of the transmissions between the Deep Space Network and interstellar spacecraft to figure out which stars these signals could reach. They also used data from the JPL Horizon system to track the past and future positions of the spacecraft. The authors found that 5 stars could receive these signals from Earth by the end of the 21st century. 7 stars could receive them within the next 100 years. This is a small number compared to the vast number of stars in the universe, but it's still exciting to think that aliens could detect our signals and communicate with us within our lifetimes. While it's normal to feel threatened by something you know nothing about, it's a fascinating prospect. Scientists and experts will remain on the lookout until a signal finally leads to confirmed traces of extraterrestrial life.